Totally amazing here. Greetings again, dear lovely viewer, the home of scientific knowledge, discovery, research and truth since the 1st of January 2K19. And today we are having a look at an autopsy on that vacuum cleaner motor. Now, you would have seen and heard me talking about this thing numerously before, and I've had a degree of difficulty getting into this, but I've now since managed to resolve that problem, as you can see from the nut on the top. It's been loosened and the impeller is now just sitting on there loosely after I managed to get into it. Now, unfortunately, by doing so, I did actually cut my hand open trying this before, so this is why you should always be using some of these safety gloves, which we have anyway. These ones are £15 and they're made by Mechanics. Framers gloves. The only drawback is it's the swearing fingers and your thumb that's exposed, but still pretty comfy nonetheless. So you'll definitely need something similar to that, and I recommend Mechanics anyway. These are a replacement pair because the other pair I actually lost. Right, now, because we're also dealing with electric motors, you're also going to want a pair of impact rated safety glasses. These ones are from DeWalt and purchased in the same place, and these were only around about £4, fairly stylish too. And again, they cover all over your eyes, so that's fine. And obviously, as a certain person who says safety is number one, yeah, well, we don't need to worry about that guy. I think these look all right anyway, but as we're indoors, we don't need to be worrying about them. So it just drops them on the floor. Fantastic. Right, okay, so then what we're going to need is to get into that motor, you're going to need several tools, and we can ignore the CV joint grease for the moment. This is obviously when it comes to rebuilding the motor. I'm going to start by talking about the CV joint grease, purely because you can get this stuff in a can as well. Well, it's sort of oil in a can, and that goes by the name of WD-40. Now, it's just a word of warning that when you rebuild these motors, don't use WD-40, and the reason being is because WD-40 is liquid-based, and it's sprayed out from a can, and it's quite possibly also flammable. Now, within these electric motors, these are rotating at some pretty rapid speeds. Well, as you'll see when we get into this thing, these are fast-moving components. And WD-40 is not really cut out for that, and as it's liquid-based, you'd be putting that in close proximity to electrical voltages, which is a dead no-no. So CV joint grease is what you would want. You can find this stuff in the mechanical industry, so vehicle technicians and motor vehicle mechanics would have this, and that's obviously for the lubrication of fast-moving mechanical parts under load. Bearings and CV joints, there's pretty much a clue in why it's called CV joint grease. And CV joint, just so you know, stands for constant velocity, which implies that there's going to be a constant load imparted on those components. And that CV joint is, that grease stuff is usually to be some sort of lithium moly or lithium polymer based, and it also has cooling properties in it. So that's the stuff you would want, and you only ever lubricate the bearings only, nothing else, but we'll come to that another time. Now also what you'll be requiring is your security bit set, a handle shaft with obviously the socket extension adapters on it. That's so I can put on a T20. So I'm just going to drop the rest of this on the floor. So let's find our T20 bit. And there it is. So that would just simply go in like so. And this kit, well, just without the bit, but the handle and that came from a company called Barco. And that's these guys here. And that's a full socket kit there. Better hurry up with this as we then get into the motor. And of course, you'll need a ratchet, a 13mm socket, again from Barco, or you can use a cordless screwdriver with the socket adapter there and use that, which is what we've done. Then you'll also need a couple of flat-bladed screwdrivers, a needle nose file and a brush. You won't need a lighter unless you smoke. So what we're going to do is we're going to actually have a look and inside this thing now and inside the motor and see exactly what's failed. Now I can tell you that I have a sneaky feeling. I mean, I've only gone as far as to remove the impeller. So what we'll do is we'll just put this all in order as well as we remove it. So let's just sort of zoom in as I explain what I think it could be. Now, there are possibilities of what this could actually be that's wrong with it. And the first thing is going to be mechanical. As you can see, I'm just sort of, as I pull everything out, I'm sort of arranging it. Now, if it is mechanical, then that's probably going to be caused by the fact that this motor has a terrifically bad design. As you can see, there's not really much there in the way of ventilation and cooling for this thing, so it could be that is the problem. What I've got to do here is just remove that metal ring. Now, there is also some electronic components in here that can go wrong, and there's one that goes under the name of what's called a triac, and this is obviously for the controlling and regulation of motor switching. Now, sometimes if these get hot or if they short out in any way, they can blow off their own gates on them, and that can be a problem. But again, what we'll do is we'll have a look at that as a possibility. But usually triacs are just fitted there as a form of switching control for the motor. And sometimes if you get a power spike across them, or they fail in some way, and then as I said, they'll just blow off their own gate, and then the thing will no longer work. And all triacs are anyway, they're just a MOSFET semiconductor. The other possibility that could be wrong with this is quite possibly, again, due to mechanical issues, probably along the line of components or something getting ingressed in there and becoming broken. So bearings breaking down or things that have caused that to happen through either heat or whatever. And the other particular problem that we could have as well is motor brushes wearing out and becoming broken. And as you can see, we're now into the device. This is now our motor. And when we turn this, let's just get some light over here so we can see what we're doing. Here we are, that's inside. And when we turn this, let's just get my fingers out of the way. You can hear that clicking and grinding and making all sorts of noise. Now that, I'm reckoning, is quite possibly due to those motor brushes and possibly a warped shaft. Now that can happen because if there's any sort of manufacturing error or heat or something like that, that could cause that shaft to warp. But what we're going to do anyway is we're also going to, let's start by removing brushes. We'll inspect those. And they do have some slight burning there. But we have a needle nose file so we can just kind of gently clean those off. Anyway, sort that out. We'll do that off camera, I would imagine, just to save time. Since our brush is removed, it's important to have them in order. So we'll just face them that way. And then what we need to do is have a look at that triac as well, just to make sure that is not damaged. Because as we can see in here, there's not much room for ventilation, so these things can indeed get hot. I'm just going to prise this open there. That top plastic piece comes off, as does the bottom. You can just reseat that in there for now. And there is our electronic component. And that three-legged affair there, you can see, I'll just point to it, that. There is your triac. And when these blow up, that middle leg there is the gate. And now I'm sure on this one, where is it? So the middle one is a gate. L1 and L2, so that's going to be terminal 1 and terminal 2. And a small voltage is applied across the gate, which will cause that to open and close accordingly. Now, sometimes when these motors, they go bad, sometimes that gate there can blow off. It'll blow open its own gates and blow off internally, and that pin can actually just become detached. But a visual inspection of that doesn't look like there's anything wrong. I can just pass over a brush anyway, just to clean that off. And what we'll do is we'll go ahead and reattach this in here, put back on the plastic cap. And while the motor is apart for maintenance, we'll just set that off to one side. Now what we are probably also going to need as well is to get that spindle off. I'm just going to come back. I'm probably going to need a hammer for this, which we have. So we have a hammer. And I'll just start by saying there's a certain girl that I'm kind of talking to at the moment, and sort of have my eye on her. And just to let you know, so here's a little bit of violence in here for you to see something get hit with a hammer. Now, unfortunately, it's not quite the destruction video we were going to do, but at least you're going to get to see something hit with a hammer. So we're just going to take the piece of socket extender, and we're going to just go ahead and crang this with a hammer and see if we can get that bearing out along with the rest of that, the whole motor assembly there. Might come out, if not, well, we might have a problem, but I'm just going to stick this on the end of the bench here and just go and hit that with. And there we are. I think that's come out. There's the whole motor rotor. And I think I also knocked off one of the metal sealing rings there as well. It's rather interesting, so we'll end up having to replace that. It's not actually off. Is it one of the bearing caps? No, it isn't. Okay, so we can just straighten that up and put that back in anyway, but that's our rotor. So it's going to be our commutator there, our rotor and rotor windings. And we're just doing a visual inspection on these. They don't seem burnt out, but those bearings, they could do with some lubrication on there. So let's just go and have a close in on this. There we go. And that's our rotor assembly. So we'll need to lubricate these bearings up anyway with some of that CV joint grease. And then we have in here our stator coils. And this is where you also get a magnetic field in these. So we're just going to check these over as well. But they all appear fairly okay. There doesn't seem to be anything wrong with that. And I'm not sure if these are actually removable from the unit. It would appear maybe, or no, actually they're not. It doesn't look like they are removable. It's unfortunate. They actually look like they are sealed in. That's those. So that's how this thing would have been in. Something like that. So what we'll need to do is we're going to clean this up. With me waving it around off camera so you can't see it. We're going to clean this up, put it back in, and then hopefully it's all going to be nice and flush. And we've got a ring there. It's also slightly bent, as you can see. Spin that. You can see that ring is bent, so we'll have to do something about that as well. But that's basically inside this, and I have reason to believe that that shaft could well be warped. That could be caused, I mean, you can see it vibrating there anyway, side to side. It shouldn't really be doing that. So it's possible that something in there is where it got ingressed into it. There is evidence of burning in there as well, so something's been getting hot. As you can sort of see, there's brushing that out, there's all bits of dust and metal coming out of it. So possible that something there has become ingressed and then gotten furiously hot and maybe caused the shaft to warp. That's possible. You know, that, I mean, these things are precision made, or maybe the these copper fingers on here, copper and aluminium fingers on the commutator, maybe they've become warped in some way. That's possible due to, again, foreign debris being ingressed into this. I suppose it is plausible. Heat build-up, and of course the mechanical strain on these brushes. I'm imagining that's what's happened. So what we're going to do is we're just going to zoom out. There we are. Get that lamp to one side. So then you get to see how this thing actually... Let's just go ahead and pull that out. And then you can see exactly how these things look when they're all pulled apart. And then you basically have... Let's just put it that way. And then go that way. And of course you have your bearing piece there. Let's just move the tools out of the way. So if you need to pause the video, you can. Then you'll have some exploded view of what these things actually look like. And then if you ever need to replicate this, you can. You'll have your 4 screws in there, like so. Let's just drop the other one in there. So this isn't just about the fault finding and autopsy of it. It's also a little bit of a stripped down guide for you as well, so you know how these things come apart. So let's just move these a little bit. Of course you've got that bearing cap, whatever that is, that seal is on the back. And of course that comes in here. That goes in with the electronic connection, and of course that's how it is. That's essentially all that's in there, not really very much at all. These are only just, well, they're only just basically just a single phase stage 1 AC motor. Nothing really too impressive about this. We are with obviously a north and a south, and you would have a north and a south here. Pass an electrical current over there, induces a rotating magnetic field, and the motor starts. That's essentially how it is. And the fault, I'm definitely assuming, is going to be with these brushes, because they actually look burnt as well. Let's just try and get the light on here. May need to zoom in on that. It's not uncommon to find some burning on these. After all, you have electrical current over there, so you're going to get some arcing. But that seems rather excessive. There's quite a lot on there. As you can see, there's definitely there at least 10 or 15 mil, and that I would argue is quite excessive. So what we'll do is we'll take our needle nose file, we'll clean those off anyway, and in the next episode we're going to look at rebuilding this thing, I reckon. Or maybe I'll just put it back together and show you it when it's running, if it ever runs again. But anyway, let's just kind of zoom out so you can get one more look at that. Let's pull that out. There we are. Just set that there. Move our tools off. We don't need our violent hammer anymore. Not now. And that's it. So what we'll do is we'll just zoom out a bit more. So there you are. That's basically the inside of your motor and the autopsy of that. And as we said, it transpires that the shaft is slightly warped. It may well be, or maybe that something there is not seated correctly. And we definitely have, look here, we can see our brushes are still not straight either. You can actually see, well, they're bent, sort of flapping around a bit too much play in there. So we'll straighten that out. And of course now we have that bent. Not sure whether or not that has actually came out bent, or whether that was already like that. It's possible that by forcing it out it may have bent it, but we'll address that problem as well. We can confirm anyway that it was not the triac. That did not blow itself up, open. No evidence of overheating in there. So electrically, all is sound and well with that. Now, just on a separate note, that three-legged component in here, if you went to try and replace one, well, good luck, because they don't actually manufacture that package style anymore. You can get something very similar if you check on the data sheet, but that very component there is not actually made anymore. It's obsolete, but you can still use something fairly compatible with that. So that's about all really for this video. I'm going to obviously go ahead now and overhaul this motor. and see if we can actually repair it now. Give the inside of the stator housing there a full clean up, because as you can see inside there, it's also slightly burnt on the inside. It's all down there. There's evidence there of burning. So something has got hot and furious. And I'm still finding little bits of shards of metal in there. So that has told me that there's been things either ingressed or that are breaking up from in there. But until the next time, thank you for watching, dear lovely viewer. Like, comment, subscribe, and of course, bang that bell, and I'll see you in the next one. Ciao.